Hello everyone, this is me Padma. In this video, we are going to see the basics of solving linear equation with some example. Let's see what is linear equation. As the name suggests, this is an equation which hold LHS and RHS which has been separated by an equal to symbol. But why I'm actually giving the name as linear equation means this will have a variable term and the highest power of the variable need to be always 1. Then only we can say that's a linear equation. We'll see the general form of linear equation, or we can say the standard form of linear equation also. Ax plus b equal to 0. Over here we have one variable term which is ax and one constant term which is b. What about this a? Actually it's a coefficient of x, and check the power of x, it's nothing but 1. If nothing is there, it means it's 1. So the highest power of x is 1 over here. That's the reason this is a linear equation. And the other name for linear equation is 1-degree equation. Let's see some example for writing the linear equation. See, I'm actually writing 5x minus 2 equal to 0. This is an example for linear equation. Here I'm having one variable term and one constant term. So that's why, and the variable degree is c. If you see the variable degree, it's going to be 1. That's the reason this is a linear equation. And I'm writing this one, 5x square plus 2 equal to 0. Will it be a linear equation? Check the variable term. So this is a variable term. What is the degree over here? It's 2. No, this is not a linear equation. The degree need to be 1. Then only we can say this is a linear equation. Since the degree is 2, you cannot say this one is a linear equation. So, and one more thing, here one term I have given as a variable term and one as a constant term. It is not necessary you have to you need to have only one variable term. You can have more than one variable term also, but the variable should be same actually. See, I can have a question like this also. 5x minus 2 equal to 3x plus 2 I am having. So what is over here? See, on our LHS also we have one variable term. On the RHS also we have one variable term. But both the terms belongs to a same variable. Like this also we can have. So this type of, if we have only one variable, we can say linear equation with one variable. Even we have linear equation with the two variable, three variable, like that also we are having. I can give an example for linear equation with the two variable. So like this also we have an equation, but we will say this one. Here also the power is 1 only for both the variable. So this kind of equation we will say linear equation with the two variable. And like this with the three variable also we can write. But in this video we are concentrating only on linear equation with one variable. Then, what is the purpose of solving this linear equation? So, wherever we don't know some value, so we will be putting the variable as instead of the value, right? Then I can easily find the value of those variable by using this linear equation concepts. So that is how we are using this linear equation. So some examples, it can be used to calculate the age of a person in the past, present and future, and to find the distance, speed, time of moving object. And also in so many geometrical problem we will use this, and in money and percentage related problem, work, time, wages. We'll see rules while solving linear equation. The first rule, if you have more than one variable term, just move on all the variable term to the LHS and move on all the constant term to the RHS. And then calculate all the variables term, and that means you are going to merge all the variable term together as a single term and club all the constant term together as a single term. The next thing is, whenever you are moving, so in the first step we have seen now moving the variable term to the LHS and moving the constant term to the RHS. So whenever you are moving, you have to change the sign. See, from equal to is there, from LHS you are moving one term to RHS. Then if this is plus, this side when it comes it's going to be minus. The same for RHS also. From here, positive term is going to become negative when it is moving to the LHS. So this rule we have to follow for sure. And the next one, if only one term left, so you already did, so many terms are there on the LHS and so many terms are in RHS. So I clubbed it together as a single term. So consider this as 4x, and here also I clubbed it together as a single term. Consider this as 12. So if only one terms of an equation, then we can move the coefficient of a variable to the other side, because we need to find the variable value only, right? So we don't want whatever coefficient existing. So we have to move that to the other side. So now this variable is with multiplication to the term x. So when I'm moving this to the RHS, then what it is going to become? It is going to become division. So this 4 is going to be the denominator of 12. Maybe here coefficient is going to be 1 by 4 for the x. So you are going to move this 1 by 4 to the other side. So what it will become? It is going to become a reciprocal. That's nothing but multiplication. So this is how we need to use when you get into a single terms on both the side. So that is what our next point. If the coefficient is in numerator on your LHS, then move that to the denominator on RHS. If the coefficient is in the denominator on LHS, then move it to the numerator on RHS. These are the certain rule we are going to follow. Anyway, we will explain with the examples also. Yes. So now start with our example. Now we are going to focus on this addition, subtraction and all. See here, there are two terms on our LHS. So it's nothing but 3x plus 5. And see, in our RHS, we have only minus 1. So I can just write it as minus 1. What is our first thing? Always keep the variable term on our LHS. So move all the constant term to the RHS. So in this LHS, we have one constant term which is 5. So move that to the other side. That means RHS. So when plus 5 is moved to the other side, first write whatever is there on the RHS. Then the moved terms you need to write. So when plus 5 is moved to this side, this is going to become minus 5. Then what is the answer? 3x. So here nothing is there to club. So write the 3x as such. Here minus 1 minus 6 is there. Minus 1 minus 5 is there. Minus 1 minus 5 is going to be minus 6. So we got 3x equal to minus 6. Now we want what is the x value. We don't want 3x value, right? So we are going to move this x to the other side. So now this 3 is in the numerator. That means the coefficient of x is in the numerator. So it's going to become a denominator when it has been moved to the RHS. So x equal to, so 3 one time and this is going to be minus 2 time. So what is the value of x for this problem? It's going to be minus 2. We'll see the next one. Yes, the next problem is 15x. So I'm writing here again, little confusion. Yes, so 15x minus 5 equal to 5x plus 10. This is the problem. Number 2, this is the problem. So what is our first step? Move all the x term to one side. That means to the LHS, and move all the constant to the RHS. So already 15x is in LHS only. And here on the RHS, one x term is there. We'll move that to the LHS. So 5x, if it has been moved to the other side, it becomes minus 5x and equal to 10 is there already in the RHS, let it be. Now we are going to move this minus 5 to the other side. So if I move minus 5 to the other side, what it will become? Plus 5. So now that means find the sum of this 15 and minus 5. So it's going to become 10x. And what is 10 plus 5? It's nothing but 15. So x equal to 15 by 10. So which is nothing but 1.5. So what is the answer over here? X is equal to 1.5. Okay. So we'll see the next question. Let's see some example with multiplication and division. So see the first question, 3x equal to 15, right? So now only one term is there on both LHS and RHS. So we will just move the coefficient of x to the other side. So now this coefficient is with multiplication with the variable x. So it has been moved to the RHS in term of division. So 3 into x, actually it has been considered like this. 3x has been considered as 3 into x. So x equal to 15 by this 3. When it is moved to the other side, it is going to become a denominator. When the numerator has been moved to the other side, it will become denominator, and the value of x is 5. So the answer over here is x equal to 5. Now the next question is x by 3 equal to 6. Then I don't want x by 3, I want x, right? So here the 3 is in the denominator. If I am moving that to the other side, it's going to become numerator. So 6 into 3. So here the value of x is 18. So this is the answer. So these are all the very simple problem. Let's see one little difficult problem. So here there are two problems. So what is this? 6x plus 1 by 3 plus 1, which is equal to x minus 3 by 6. First, if I see over here, 1 is a constant, I know for sure. So what we can do, we'll move this 1 to the RHS, and here see in RHS we have this variable term. So move that to the LHS. First step we'll do that. 6x plus 1 by 3 minus, put a bracket, because this whole term moving from RHS to LHS, and it is positive. So when it is coming to the LHS, it's going to be negative. And this plus 1 is moving from LHS to RHS, so it's going to be minus 1. Now take an LCM of 3 and 6. What is the LCM of 3 and 6? 3 one time and 6 is 2 time, again 2, 1 comma 1. So the LCM is 6 over here. So what will be 6x plus 1 into 2 minus x minus 3 equal to minus 1. Now see here, the denominator is a common denominator, so we can move that to the other side. So 6x plus 1 into 2 minus x minus 3. If I move the 6 to the other side, so it's going to be minus 1 into 6, which is minus 6. Yes, now 2 is common for 6x plus 1 now, so just multiply it. 12x plus 2 minus x, minus into minus is going to be plus 3 equal to minus 6. Now segregate all the constant term to the RHS and all the variable term to the LHS. So what it is, 12x minus x, so it's going to be 11x, and here 2 and 3 is 5. So if it has been moved to the other side, it's going to be minus 5. So x equal to minus 6 minus 5 is minus 11, divided by this 11 will come to the denominator. So x equal to minus 1. So this is the answer for the first question. Let's go with the second question. Yes. See the second question. We have both numerator and denominator with variable, and in your RHS we have 1 by 5. So the easier way to do this, whenever we are solving the linear problem, our objective is to first remove the denominator. Okay, so how can I remove the denominator? First you need to make the denominator as a common denominator, then we can move. But here see, it's already in common denominator, so directly we can do the cross multiplication. So this 5 is going to come here as a numerator, so whole bracket you keep. So y minus 4 minus 3y, and here this denominator is going to become a numerator on the RHS. So put a whole bracket, 2y minus 3 plus 4y. Yes, now we are going to start doing the simplification. First we'll simplify inside the bracket, then we will multiply that with 5. So y minus 4, minus into minus is going to be plus 3y. And here it's going to be 2y minus 3 minus 4y. So what is going to happen now? 5. So y plus 3y is going to be 4y minus 4. And here 2y and minus 4y is going to be minus 2y minus 3. And here 5 you multiply with both the terms, then it's going to be 20y minus 20 equal to minus 2y minus 3. Now move the variable term to the LHS, 20y. So this will be coming this side, so it's going to be plus 2y, and here minus 3, and this minus 20 moving to the RHS becoming plus 20. Yes, now here the answer is 22y. The 20y plus 2y is going to be 22y. Minus 3 plus 20 is going to be 17. So what will be our answer? It's 17 by 22. And check, is there any common factor exists between these two numbers? No, there is no common factor. So this is the answer. If there is a common factor, we need to cut the common factor. So